In this video, we are going to go through the answers for diagnostic tests on dynamics. Let's start with question 1. What's the definition of force on a body? Newton's second law defines the force as the rate of change of momentum. Right, so the answer is C. Okay, looking at the graph for question 2, it is a momentum versus time graph. Right, so since the force is given by the rate of change of momentum, okay, so we expect the force to be given by the gradient of the graphs. All the graph has negative gradient, right, and the force is 10 newtons. Right, doesn't matter, this just shows that the force is in opposite direction to the motion. And just look at the one with the magnitude of 10 newtons, which is B. Alright. Question 3. How much does the momentum change? Given the force time graph, we will be looking at the area under the graph. Alright. Okay, why so? Is because the area gives me the impulse. Alright, so the impulse is equals to the change in momentum. Okay, so the area here is given by the sum of this square here, which is 2 times 2, and this trapezium here, right, which is just half times the sum of the sides and 4. Okay, so sum up all these, you should be able to get the answer C. Question 4. We have got steel pellets, each of a mass of 0.6 grams for vertically. Alright, this is at the rate of 100 pellets per minute. Okay, so using Newton's second law, we have F equals to N dP dt. Okay, and because they fall at the constant rate, change the derivative to just the change of momentum and change of time. Okay, how many pellets are there? There are 100 pellets, and change momentum for each pellet is the mass times the change in velocity. Now take note that for the velocity, you have the pellets coming in at 5 meters per second, and then it rebounds with a velocity of 4. Okay, so in terms of the velocity, it's opposite direction, so it's actually minus 4. So the change in velocity here is actually of 9 units. Alright, so here the change in velocity, you have got 9 units, and the time taken is 1 minute, so it's 60 seconds. Evaluate this and you should be able to get the answer 0.0090 newtons, which is C. Question 5. With two bodies and no other forces acting between them, so if the force acting on P is F, by Newton's third law, the force acting on Q should also be F. Alright, so it's either C or D. Let's find the acceleration. Okay, so the force are the same, so the force on P is MP AP. Okay, and the force on Q is MQ AQ, and hence the acceleration of Q is given by MPAP over MQ. So that's D. Okay. Question 6. You have a balancing weight, which is balances a passenger car. Alright, this is a more tedious. You have to work it out using free body diagrams and Newton's second law. Okay, so let's look at the balancing weight. For the balancing weight, there is a mass of 640, so the weight here is 640 G. Alright, of course there's a tension in the rope. Okay, read the question here. It only wants us to find the acceleration of the car. Alright, although the passenger is in the car, the passenger is accelerating the car. So effectively, we can treat the passenger and the car as one object. Okay, and also the tension on this system, it's T, and the total weight of the passenger in the car is 600. Alright, because 520 plus 80 is 600, right? That's the total mass of the passenger inside the car. Okay, so 600 grams, 600 G. Using Newton's second law, I can write down two equations, one for the weight and one for the passenger car. Alright, and if you were to solve these two equations, you will be able to get the acceleration equals to 0.32 meter per second squared. Okay, answer is B. Now look at question 7. Okay, question 7 is about the relative velocity of approach and relative velocity of separation, and you should be able to memorize this. U1 minus U2 if there's a perfectly elastic collision, right? This is the relationship between the velocities. Okay, but the question is quite tricky in that it has defined the velocity for you here, initial velocity, as in the opposite direction. So when you take u1 minus u2, and if I were to take right as positive, u2 here is actually in the opposite direction, right? So this is actually minus u2. So the answer is D. Question 8. Right, you have two trolleys. The mass of X is twice of Y. Okay, now the key idea behind this is that you have to note that they are at first stationary, okay? So when they are stationary, what's the momentum? The total momentum of the system, when they are stationary, the initial total momentum is 0. Okay, now we're looking at total momentum. Now, doesn't matter what happened before and during or after collision, okay? By conservation of momentum, the momentum of the system, by system I mean both X and Y, the momentum must always be 0 by conservation of momentum. So they can go towards each other and they stick together, but after that, their final momentum must be 0 by conservation of momentum. Alright, oops. Okay, so the answer is A. Okay, question 9. What's the kinetic energy loss during the collision? Alright, so for this question, you have to work out the velocities after collision, right? So they stick together. And I can write down the initial momentum. Initial, it's opposite direction. So for this one, I have got 5,000 minus 1 equals to the final V. So V equals to 0.5 meter per second. Alright, that's the final velocity. After finding the final velocity, the rest of it is just maths, just calculations. Right, I will have to take the loss in KE equals to the final KE minus the initial KE. Okay, so you can just go find out the initial KE by taking the mass, half mv squared. And the answer should be C. Alright. Question 10. You have an object. Initially, the velocity is 0. Okay. Then it explodes and then it separates into two masses. Okay, so by conservation of momentum, you have the initial momentum is 0. Alright, because initial velocity is 0, so initial momentum has to be 0. 0 equals to the final momentum. Okay, final momentum is 2mv y. Alright, then x is moving in the opposite direction, so minus mvx. Okay, and from here we know that the velocity of y, the velocity of x is twice the velocity of y. Okay, and if I want to find the ratio of the kinetic energy, Ke of x and K of y, it is just half m vx. Right, express everything in terms of x. Okay, half, this is the mass of y, and okay, so I can cancel away the common factors, and this will give you 2 over 1. Okay, answer is C.